Today we're going to be talking about the second derivative. First, how to find the second derivative, and second, the applications of the second derivative. I hope you enjoyed today's lesson. We've been talking in our last few lessons about the first derivative and the second derivative, and I just wanted to touch on a few points briefly here on how we use those. For example, let's talk about problems involving the first and second derivatives. If you know what the first derivative is about and you know what the second derivative is about, these problems become rather easy. Find the stationary points of inflection for, well, before we even go on, you have to have this in your mind, that a stationary point of inflection is either that or it's that. And you know, at that point, right away you should be thinking f dash of x is equal to 0 and f double dash of x is equal to 0. That's what happens at a stationary point of inflection for this particular function. Well, this is y equals. First, we'd have to find out what f dash of x is equal, and then set it equal to 0. Because that's how we find stationary points. Remember, we have maximums, minimums, and stationary points of inflection. That's part of our stationary points when f dash of x is equal to 0. Once we find f dash of x and set it equal to 0, how do we know it's a stationary point of inflection? Well, you can go a little to the left and a little to the right and see that the derivatives remain the same sign. For example, a little to the right over here, we have positive derivatives. A little to the left, we have positive derivatives. That's a great test to make sure you have a stationary point of inflection. Here, a little to the left, we have negative derivatives. A little to the right, we have negative derivatives. Again, a great test for stationary points of inflection. And again, once you know that, you could confirm it by looking at f double dash of x and seeing that the second derivative at this point in question is also 0. In example 2, it says, show the curve with this equation, y is equal to x to the fourth minus 4x cubed, has a non-stationary point of inflection at x equals 2. Well, a non-stationary point of inflection is the most negative derivative, or it's the most highly positive derivative if we're thinking about the slope of that tangent right there. Well, what does that mean? I have to know for non-stationary points of inflection right away that f dash of x clearly is not 0, but f double dash of x is equal to 0. So I have to investigate first what is f dash of x, and then I'd have to find f double dash of x. That's a great way to start this problem. Find both the first and the second derivative, and show that at x equals 2, the first derivative is not equal to 0, but the second derivative is equal to 0 at x equals 2. Again, same with this problem. We can look a little to the left and a little to the right, looking at the first derivative and see a little to the left, my first derivative is negative. A little to the right, my first derivative is negative. If we're talking about this point in question, a little to the left, my first derivative is positive. A little to the right, my first derivative is again positive. That's a great test for in the first derivative for a non-stationary or a stationary point of inflection. Example 3, find and classify all stationary points of inflection. Sorry, all stationary points, which makes us think maximum, minimum, stationary point of inflection this way, or a stationary point of inflection this way, and inflection points, which could also involve our two non-stationary points of inflection. Well, we'd have to go through the whole gamut here, looking at the first derivative, the second derivative, and following our rules. For a stationary point of inflection, both the first and second derivative are equal to 0. For a non-stationary point of inflection, our first derivative is not equal to 0, while our second derivative is equal to 0. And then we know for a minimum and a maximum, we have positive derivatives followed by negative derivatives for a maximum, and for a minimum, we have negative derivatives followed by positive first derivatives. But usually the first step in all these problems is to find f dash of x and set it equal to 0. That's looking for stationary points. Find f double dash of x and set it equal to 0. That confirms that you have a point of inflection.